The lighting of a game is a major element in setting the mood of the game, providing an overall color and look of the game, telling people how they should feel before any action happens. In this chapter, we'll light our Zombie Toys game here in the Unity editor. Before we do that, let's take a look at some examples of amazing lighting in-game and contrast that with non-real-time rendered lighting. This is the Atom demo, a short film put together and rendered entirely real-time in the Unity editor. What we can see even from this first scene in the Atom demo is there's two radically different ways of lighting and an absolutely expressive mood contributed by the lighting in this scene. This is also combined with the overall material, color, model, and post effects, and all of these produce that mood in here, but the lighting is central. We'll go forward a little bit more and look at other parts of the Atom demo and really see how lighting sets the mood for this particular room. In this scene, the lighting coming from that single window behind the main character serves to add rim lights on here and reinforce the overall darkness and despair in the room. The lighting and the color, plus the bloom and the post effects, really sets out that empty and cold feeling. If you'd like to view the full Atom movie, go to unity3d.com/pages and Atom, and take a look at the whole movie as a really amazing example of real-time lighting. When we look at Made with Unity, there's other terrific examples of lighting setting the mood in the game. Here's Oz Broken Kingdom. The overall lighting is actually quite warm. It draws its hints from that yellow brick road. However, the shadows are purple, as are many of the rim lights on the monkeys and other characters. This combination of the consideration of lighting in highs, midtones, and shadows really serves to put a definite mood in, that overall we're at least excited by that yellow brick road, but there's a definite amount of fear because of those cool tones in the shadows. The biggest concern with lighting in games is that it has to be real time. There's simply no time during the course of the game to calculate the lighting. It has to happen instantly. When we take a light and we put it in, such as a point light here in the scene, we'll see that anything we do, such as moving this light around, increasing its range or intensity, shows up instantly. And this is where games really differ from film and other visual effect driven pieces such as commercials. This lighting is real time as we go around, as we move the light, and as things react to that light such as animated characters. In contrast, here in Autodesk Maya, I brought in the dollhouse and lit it with a physical sun and sky. And we can see and hear a difference in the lighting in just one frame. I've pulled up my interactive photoreal renderer, and we can see in here, even though I have a fast computer with a fast GPU, it's still taking a second, or actually several seconds, to calculate the lighting. There is a difference though. In pre-rendered lighting, we see a greater fidelity in the shadows, the light bounce, and the overall resolution of detail, whereas in games, we do as well as we can in real time, and we often augment that with light baking, pre-calculating our lighting and caching it ahead of time. In this chapter, we'll look at lighting our Zombie Toys game, calculating in a very specific mood and providing a unifying ambient color to really pull the scene together. Then, In the next chapter, we'll look at baking the lighting, pre-calculating as much as possible to relieve the load on processing during game time, yet still having our lighting with its definite mood and shadow apparent in the game.